checkpointing is when a program is able to save progress periodically to a file and resume from that saved file to continue running, hopefully losing no progress whatsoever, certainly losing minimal progress. And by minimal in that case, what we usually mean is there's a certain amount of overhead to restoring that state off of disk and then being able to proceed as if you had never stopped in the first place. So why would you want to checkpoint? Why would you want to go through the trouble of writing your state out to disk and reading it back in? It seems like it's a lot of work and it's going to take a lot of time. And the answer is that interruptions happen. Sometimes those interruptions are unavoidable, hardware or networking failures. Right? The network goes down, your machine blows up, or the machine you're running on blows up, excuse me. More common are cluster and node policies. A lot of people, a lot of admins have a policy in place where, say, you can only run your job for 8 hours before you get kicked off, saying you've had enough time. If your job needs 9 hours to finish on that node, you're never going to get anywhere. So you might want to think about some self-checkpointing. This also applies, except even more so, on opportunistic or backfill resources, where they may not have a policy about how long you can run, but in practice, maybe you get 15 minutes, maybe you get 24 hours, and there's no way to know. So what self-checkpointing does is allow you to make progress through those interruptions. And this is particularly important for long-running jobs, right? If your job only runs for 20 minutes and has to restart from scratch, maybe it doesn't really matter. Requirements for self-checkpointing, and I'll explain the difference between checkpointing and self-checkpointing. Actually, I'll do that right now. In Condor, which is the context we're talking about this in, the job has to write its own checkpoints and then tell Condor that it's done. We'll get to how that happens in a second. It is at least theoretically possible for there to be a service where you could have this happen externally. So in every case, when I say checkpointing throughout this talk, I'm talking about self-checkpointing, excuse me, which is where your job, your executable, your application writes these checkpoint files out of its own accord. So you need to be able to checkpoint and restart in order to be able to use self-checkpointing. Specifically, you need to be able to periodically write that state file we were talking about. You need to be able to restart. Your code needs to be able to find that checkpoint file and resume from it. And that's without changing any arguments. Condor, when it restarts this checkpointed job, will go ahead and start it the second time exactly the same way it did the first time. It will need to exit in two different ways, at least. The first one is an exit code saying, I've written out a checkpoint file, please go send it somewhere safe so we don't lose it if the machine goes away. Or if I get kicked off, or if the opportunistic resource decides it has better things to do. And then the second one saying this is the end of the job, one way or the other. It's conventional to use 85 for the I have written the checkpoint number. And it's of course conventional to exit with 0 when the job is over and done with successfully. Some of this may not be directly possible with your application the way it currently is written, so you might need to use a wrapper script to make it happen. The other thing, of course, is you need to be able to checkpoint sufficiently frequently. Unfortunately, that's how often is frequently enough is it depends. It depends on your code. It depends on the available resources. You know, if your code, is only ever going to run on resources that checkpoint or that kick you off every 8 hours, you only need checkpoint every 7. Context here, of course, is HTCondor, in which the self-checkpoint executable is going to be run many times, each time to completion by Condor. This is a tutorial, so we're going to be assuming that Condor is managing the job files, just to make things a little simpler for me. That is, it's not using a shared file system. This talk applies to jobs in the vanilla or the Docker or the container universe, which we haven't spoken much about yet today, but those three. The features discussed, that is self-checkpointing, first became available in 8.8.4 and 8.9.3, and some improvements as of 9.06, which will be significant to the talk, and I'll mention again. And some bug fixes in 9.0.11, and 9.3.2, and 9.5.0, and 9.5.1, and in 9.10.0, which is not even out yet. So I'm really glad that people are using it and finding bugs. That's wonderful. Thank everybody who sent in those bug reports. It really warms my heart to know that people are actually using this. Those bugs will not come up for anything that we will be covering in this tutorial. Just to give you an idea, try to explain the kind of life cycle of the self-checkpointing job. So this is a single, well, this is actually 4 n executions, but after each executable run, each time it exits in this case code 85, and it produces these nice little yellow files that are the checkpoint files from our example. Thank you. we will only be using a single checkpoint file again for simplicity. So it exits with a specific code when it checkpoints, and a final exit code, hopefully 0, meaning everything is okay when it's done, produces this green result file. On its own, the way things are set up, the way the requirements are written, the executable will never finish. Right? It will get to the end of the first checkpoint and just stop. So there needs to be this external process, and Condor is that external process that restarts it at these intervals, so that it can finish. So the question is, why are we stopping at all? And the answer is to let Condor know, right? This is now the time that I've written this checkpoint out. It is whole, it is complete, and I'm not screwing with it. So you know that if you copy this whole file or this whole set of files, you get my whole checkpoint. Oh, and I'm saying when I say copied off to a persistent location, that does mean currently back to the submit node. And that will become important later on. So that Condor can go back to the submit node when it needs to start the job and get the checkpoint back, even if the previous node that your executable was running on has gone away or become unavailable, inaccessible. In terms of turning this explanatory diagram into Condor submit file language, at the executable is this nice gray arrow, the checkpoint exit code, and you must specify a checkpoint exit code if you want to get this behavior. Even if the checkpoint exit code you're using is at 85, you have to explicitly tell Condor, I want you to restart the job when it exits to take a checkpoint. You then need to tell me what your transfer checkpoint files are. There'll be an example of that in just a second here. If you're using Condor before 9006, assuming I'm remembering that version number from the second slide correctly, you will not get your standard out or standard error preserved unless you specifically list them in transfer checkpoint files. In this case, we only want our standard output log. We don't care if the error log says for some reason. So we're only going to list Condor standard out there. To be clear, after 906, both of them will be preserved, whether you ask for them to be or not. I'm going to go over quickly just to give people an idea. Maybe not quickly, but anyway, we're going to go over the file exchange, right? What happens on which machines, and which files are created when. So you submit the job from job.submit, which is a nice generic name. Executable.py is this the executable you're running. Creates the job.log file for you right away. Eventually it gets scheduled, and we do file transfer over to execute node N. That is important. Notice that for later. We have our executable, which is that gray arrow from before. And Condor creates these two Condor standard out standard error files. And those are where it's keeping a copy of the output and error streams that your executable produces. It runs for a while. It produces checkpoint.txt. As I said, in this case, this is your only checkpoint file for simplicity. It exits with code 85, meaning I finished writing my checkpoint file. And what Condor does, without leaving the machine it's currently on, is copy those back to the spool directory on the submit node. It copies back checkpoint.txt, because you told it to. That's the yellow files there. And Condor standard out, because that was also in your checkpoint file list. You don't need to do that in 906. You'll notice that Condor standard error is not copied back, and therefore it will not be preserved. Then it just resumes, re-executes executable.py in the execute directory on execute node N. This happens as often as it takes. At some point, it will probably get interrupted. All this stops happening, and you're just left with the stuff on the left-hand side of the screen here. Job goes back to idle because it was interrupted and got kicked off. When it resumes, it transfers its input files again, which in this case are just the executable. And it also transfers the checkpoint that you put in the spool directory. So checkpoint.txt from Condor standard out. Condor recreates the Condor standard error file on your behalf. And we repeat the cycle until the job finally exits with exit 0, produces this nice results.txt file. The results.txt file is copied back. It is copied back before we remove, and this is important, before we remove the spooled checkpoint files, because until we get that results file, your job is not actually done. And then so this is what we end up with at the end after the checkpoint files are removed from the spool directory. Thinking about output files really briefly in this context, it's the same mechanism. We use the same mechanism to transfer output files and to transfer checkpoint files. By default, of course, as you heard this morning, new files are transferred back to the submission directory. That's how you specify other ones if you want to. It uses the same format and specification as, transfer checkpoint files uses the same as transfer output files. I already covered those other 2 lines. Thank you. If you want to test your job, and you probably should before you send it out into the great wide world, you can simulate a job interruption. It actually does interrupt the job by running Condor vacate job and then give it the job ID. That will then send your copy your checkpoint files over the Condor evicted files, into the spool directory. You can use Condor evicted files in the job ID to get a list of those files in their location. If you want to poke around in the spool and see what's there, you can use Condor config-val spool to find that directory name. If you want to know what Condor transferred or what it thought it was doing, the job log is a good source of information regarding file transfers. Things you should think about when you're starting to use self-checkpointing. You want to know how this is going to scale up before you actually do it. You want to think how many jobs are going to checkpoint, how much data does each job use, and what's that total come up to? In a lot of cases, but not all, in some cases, I should say, but not all of them, the system administrator will have spool set up to charge against your user's quota back on the submit node. For the ones that don't, it gets a little dicey if you put too much stuff in spool that can cause other users problems. So think about that total, be careful not to exceed whatever it is. Maybe talk to your system administrator first. So you definitely want to avoid filling out the spool directory. You also want to avoid transferring large checkpoint files. As I said, it's this multiplication. It's the multiplication. It's the total amount of data you're sending. If you're sending 100 small files, it's probably okay. If you're sending one single gigabyte file, you've got 1,000 jobs. It's probably too much data for spool. You also need to think about, in terms of best practices, what the checkpoint frequency for your job should be, right? How often do I want it to checkpoint? That depends, right? That's an expert answer, right? How long does it take to produce a checkpoint and then resume from it, right? If it takes you 10 seconds to produce a checkpoint and 10 seconds to resume from it, you can checkpoint really often and lose a very small amount of work. If it takes you 5 minutes instead, maybe you only want to checkpoint once an hour. And of course, that's balanced by how likely your job is to be interrupted. If you know that your machines are extremely reliable, if you know you're only running on a particular pool, then you can tune how often you take your checkpoint to whatever that pool's maximum job duration might be. You definitely want to spend more time running than checkpointing, right? You don't want to make a reasonably efficient use of the resources you can get given. And if you know your first checkpoint is going to take an hour to run, but for whatever reason you can only run for 45 minutes on your resources, there's no point in even trying to submit them, right? Bothering to submit them. This has all been assuming those requirements that I talked about. Sometimes even with the wrapper script, you will not be able to get your executable to behave in that way. Some executables will write checkpoint files and just keep right on going. There's no way you can get them to stop. If that's true, you can try this alternative checkpointing method. It's not as reliable as checkpointing based on an exit. This is called checkpointing, or this is eviction-based checkpointing, where you try and say, okay, well, Condor stopped the job for me. That's what happens when it gets evicted. And we're going to try and copy that last checkpoint out before we get kicked off for good. You can read about that in the Condor submit manual page. That link is live. You're looking for on exit or evict. That says, just transfer my output files when I get kicked off this machine. And of course, if you're the problem with the interruption that's occurring is because of hardware issues or network partition, this doesn't work at all, because then you can't transfer your checkpoint file back no matter how fast it transfers. These are some resources. There was a much longer and better narrated version of this tutorial that had a demo in it. I guess that was HTCondor Week 2021 down there at the bottom, which I highly recommend everyone who's more interested in this take a look at. Oops. Otherwise, if you have questions, please ask them now. Thank you.